Hello and welcome to another episode of AWS Cloud Bytes. I'm your host Bhavesh Kumar. Today we are going to talk about demystifying SQS and DLQ pattern, and we are going to talk about how this pattern can be used to reliably handle your messages in AWS. And I have some benefits and best practices, but before we jump into that, let's think about a scenario where you have a payment processing service and the service is failing to process customer transaction due to maybe a malformed message or maybe the database is down temporarily. So what should you do? Should you not perform these transactions because that is going to be a loss to business? Or you should retry indefinite time until you succeed, which is going to put more pressure on already stressed out system due to some outage. So what you should be doing in order to handle these kind of situations, Amazon provides you a decoupled architecture. It's not just Amazon, but it's basically a queue-based architecture where you, rather than having a synchronous transaction from end to end, performing a success and then going back in real time, you do it using queues in the middle. This is where Amazon SQS with dead letter queue becomes a powerful pattern for handling failures gracefully. Let's look at the pattern in detail now. So let me scroll to the picture. That will give much better idea. And maybe I should reduce this a bit. If you look at this picture, there are some numbers over here, and we'll talk about from here how things flow. This is your application. Maybe this is your payment processing application. It is going to act as a publisher here, which means as soon as there is a payment request, an order is being processed, and an order payment has to be made. So in order to look into this particular example, I have, rather than going by a payment processor, I have just used as an order being created as an event. Now in the publisher is saying that an order has been created. It's number one here. Then there is a queue that holds the order. So you have main queue. This is the main queue where the order is surfacing. The message is stored in this queue. And then you have a subscriber. Now in this case, we have kept one-to-one, but in case an order has been created and that has to be notified to multiple parties for that particular event, you can publish it using an SNS. So SNS can be used in that case, but this is an SQS pattern that I'm trying to narrate. So let me delete that. Assume that you have subscriber that is subscribing to this queue. You have an application that is reading from that queue and processing those messages. So the subscriber is nothing but an application that pulls a message out of the queue and then processes that messages, puts that message in a DB or performs some actions and then uses an SNS over here to notify multiple interested parties, maybe a shipping or any other service that is dependent on its processing. So let's now talk about what it is doing. The action it is performing is it is picking a message out of the queue and then processing that message and sending this information back to the queue whether it was successfully processed or not. Now, if it is successfully processed, the message is removed from the queue. If it is not, then this arrow over here, you can see this arrow. This is basically a retry that we set on the main queue, saying in case the message is not processed, I would like to retry that message to be reprocessed. And you can set it from any number, but maybe 2 times the retry that we are looking for, 2 retries. Now, going to this one, the publisher keeps on publishing. So there is a disconnect between the publisher and the subscriber of the message, which means the subscriber can work on its own pace, while publisher can publish in case there is a spike. So suppose the message is coming like this, you have 100 messages coming every minute. And then suddenly there is a spike and then comes back. So you have like 300 messages here, 300 messages here at this level. And then the spike goes down. But the beauty of this is that you will be able to handle the spike just because the messages are going to sit in the queue for a longer duration. And the subscriber can work on its own pace to consume these messages. So that's one benefit, that there is no silent loss. The message durability depends upon how you are setting, how long you want to set this message over here. You can do it for hours to days, depending upon the configuration that you put in SQS. And then there is a operational visibility over here that will come when the DLQ, we'll discuss about the DLQ. And what happens is, suppose you set retry is 2 times, an initial message was processed and 2 retries were performed by subscriber and all 3 failed, the message will move to a DLQ over here. DLQ or dead letter queue. Now, what happens is, as soon as the dead letter queue receives this message, you can look into the approximate number of messages that are visible in the DLQ and hook into this metric to raise a CloudWatch alarm, and you can send this information to other consumers. It can be an SQS, it can be an SNS topic, it can be sent on a Teams chat, it can be sent as an email or a Slack message. I have not done integration with the Slack, but I believe it will be easily possible if there is a webhook or if there is an email address of Slack. Like Teams can do a Teams channel as well as using the email. I have done that. So the idea is that as soon as there is a message in a dead letter queue, which means there is at least one failed message, if you put that alarm that way, that if the metric is greater than 1, then, or greater than 0, if the message is greater than 0, sorry, this is not writing correctly. If it is greater than 0, then in those cases, just raise the alarm. Now somebody, so suppose there is an operational guy over here, he can actually go and look into the DLQ, and we can reprocess the message. If there is a issue with the message body, or if there is a missing attribute, that can be looked into. So the second benefit is operational visibility. So there is a visibility over here to the operational folks. And then there is error isolation. You can see what error messages are happening in this particular queue, what messages failed and what kind of errors are happening. So you will get information about bad messages, and these messages are not going to block your good messages and your overall flow. So the business will keep on running. In order to do the operational efficiency over here, usually if you don't build a UI on top of it, your operation team will have to go and replay the message by using the redrive. Let me delete all this. Viewer here, there is an operational guy, and this guy has to go look into the DLQ and then put it over here by using the redrive feature that is provided by AWS. Initially, it was started with the standard queue. Now it is also available with the DLQ on the standard as well as in FIFO. So one way is to allow them to use the AWS console to do this. The other way is that you can provide a UI over here and then have a Lambda or any other compute that you want that can listen to the UI, where you can say messages A, B, and C, all 3 messages I want to redrive to be queued. Like you can just redrive independent messages or retrieve all of them. So that can be done. But that is overall the pattern. Let's talk about some best practices. Let me go to the benefits. Now, the benefit is there is no silent data loss, which means there is a durability in message. There is a operational visibility. You can inspect the failure pattern in case there is a set of bad messages. You can always go and inspect about those bad messages. Now your retries are decoupled, which means you don't do a retry in your consumer or the subscriber side of it. If you look at it, this is how the subscriber is. So this is your subscriber. You don't write a logic to do a retry in this rather than the queue is doing the retry for you. So that's a decoupled retry. Then you have error isolation, which means the bad messages are not going to block the queue. What are the best practices? The best practices are when you are doing retries, yeah, max retries, maybe 2 to 5 is a good count. 5, I believe, is on the higher side. Maybe 2 is good or 3 is good. So that's a range you should be looking into depending upon how often or how much you want to do a retry per message. And we are not talking about one message at a time because you can send a batch. So you can send a batch of 10. Each subscriber can actually pick 10 messages and retry 2 times for each message in case all of them are failing. So you can think about the time it is going to take at the subscriber side to do that much retry. So always be cognizant about that. Now, I've seen like you have a DLQ. People do set up the DLQ, but they forget about setting up an alarm on the DLQ, which means messages are failing, but the operation team doesn't know anything about it, which is something that we should be avoiding. It's best practice not to do that. That's why always monitor the DLQ. And it's very easy to set up the alarm in CloudWatch, given the message has arrived in the DLQ. So that metric is available. You can always use that metric to raise an alarm. And then operationally, if you want your operations team to be not coming into AWS console, you can always build a UI and perform reprocessing using the redrive through a Lambda or any other compute instance that you are using, maybe ECS Fargate, or if the organization allows them to go to the production and do the replay, they can perform it, depending upon what kind of compliance requirements are within your company. The common pitfalls I would say that we should be avoiding in this pattern, if you look at this, you should be avoiding the infinite retry loop, which means you set the max retry to be a very high number. It is going to waste your resources and it is going to delay all the messages that are being processed because the queue is going to have a lot of messages backed up. Also, you won't be able to see the messages in the DLQ, which means there will be delay in identifying the issues. Unmonitored DLQs are another issue that you will miss on data corruption bugs in any upstream changes. Summarizing this short video, the SQS plus DLQ is a foundational reliability pattern in AWS. It helps you avoid data loss, observe failures, and build resilient pipelines that don't crash when one message goes rogue. If you are using SQS but haven't configured a DLQ yet, this is your sign to go do it. Drop a comment if you have built cool retry strategies and subscribe for more cloud architecture breakdowns. This is your host Bhavesh Kumar signing off. Thank you.